Okay, so what we want to know is how do we subtract two vectors. So let's say I've got a vector A and I've got another vector B, and I now want to know what is vector A minus vector B. Okay, so what do we know already? We know how to add vectors, we know how to make vectors negative. So I can write this as, well, I can write this as A plus the negative of B. Right, so I haven't really changed anything. If I want to calculate what is 4 minus 2, I can say it's 4 plus minus 2. So that's exactly the same thing I'm doing here. We know how to do this. So we know actually what negative B is going to be. No pun intended there. That was accidental. So we can change that around and we know, well, then we got negative B. We know how to add vectors, so what we must now do is we must take A and add to that vector negative B. So graphically, I can take vector A, at its tip, I now place vector negative B. Sorry, it should point in the same direction. I'm just not drawing very good or very well this evening. So at its tip, I place vector negative B, and if I join the two together, what I then get is the total, which is vector A plus the negative of B. So this vector over there gives me the difference between the two. Now, if I were to draw in the vector positive B, remember it's the opposite of negative B. So positive B would be somewhere over there. Now, I can also, if I draw a parallelogram, I can say that would also be, it's got the same, that side has got the same magnitude and pointing in the same direction as vector B, so it's equal to vector B. That side has got the same magnitude and the same direction as A, so that is like vector A. And if I look carefully here, I see if I connect these two, so I draw A and B from the same point, I connect the tip of B to the tip of A, what I end up with is just exactly the same as that I've got over there, which has to be vector A minus B. So graphically, what you can do if you need to subtract a vector A from a vector B, you can draw A. From its tail now, you can draw vector B. And if you connect the tip of B to the tip of A, what you get is the vector A minus B. And I could do all this because we've said, well, as long as I keep magnitudes and directions the same, things remain equal. So it doesn't matter if I draw A there or there, B there or there. As long as I just keep the magnitudes and directions the same, I could now graphically at least figure out that, okay, from this definition, I could figure out what A minus B should be. By playing around a bit with where I draw the A's and B's, I found, but hold on, if I connect the tip of B to the tip of A, when I've drawn them from the same point, that side over there just gives me exactly the same thing. So I want you to remember this picture. You can go and look at this. I will post this on YouTube as well. It's in the slides, so you can go and figure out my reasoning at home. But what I want you to remember for tonight is just this picture. If you see one vector, and from the same point you see another vector, if you draw an arrow from the tip of that one to the tip of that one, what you get is the difference between the two.